Okay, I believe this is approximately where we left off with yesterday, okay? And again, we're just talking about general characteristics of, as you can see, that of the endocrine system. Now, cell-to-cell communication, that can be both neuronal and hormonal, okay? Because different types of hormones can cause different types of effects over the course of the human body, okay? And when we talk about hormones versus neurotransmitters, of course, we're talking about this here. It's over a very short range and the action is very quickly. That's why we snapped our fingers yesterday using that as an example. That is a synapse, kind of like snapping your fingers. Okay, so as we move forward, okay, there are two categories, okay, when we look at that of hormones. Some of them are amino acid based. That's what the majority of them are. But if they are steroid based, which of course there are those as well, but not quite as numerous. If it is a steroid hormone, it's going to be derived from this compound here, cholesterol. Okay? And for a lot of these, when it comes to steroid hormones, I suppose you could say it has to deal with the metabolism in the body, some directly, some indirectly. That's what makes this chapter or this type of a field of medicine, I don't know if you want to say difficult, but it's just not an easy topic because it's pretty in-depth material. So we just try to get you ready for taking the next step, just having some of the basic background information to allow you to be successful next time you see this content. And something that you would not think of, and probably because you haven't ever been taught that, hormones actually can have an effect on blood pressure as well. Not just because not just because the heart is beating faster, okay? That's not really going to have an effect on blood pressure. It just means it's just moving through your body a lot quicker. There are two ways that hormones can actually, let's say, have an effect on your blood pressure. One is you can dilute that blood, okay? And what we mean by dilute that is actually putting more water into there or taking more water out. Because that's one of the things that your endocrine system does, working with that of your kidneys, for example, to actually retain water. So if you are pulling more water out of the blood, it's going to become more thick or thicker. Or if you're putting more water into the blood, it becomes more thin, and that will therefore change how easily it is to pump throughout the body and will, of course, have an effect on the blood pressure. Okay? Another aspect is having hormones that will actually cause your arteries to constrict or to relax. Constrict or relax. And of course, the best example to look at that is, for instance, to try to be precise upon pouring a solution into, let's say, a beaker, or that to measure it in a cylinder, you might use a funnel. So if you're using I don't want to say a really viscous liquid, but something that can pour pretty easily, whether it's water or alcohol, once you pour that into the funnel, it actually speeds up because it's going through a smaller spout, okay? Or probably the one you can see even more is when you put your finger or thumb over the end of a garden hose, okay? Same amount of water is going through there, the opening is just smaller, so therefore the pressure is increasing, okay? So those are two examples of how to raise or lower your blood pressure, which hormones can have an effect on that. Okay, I just wanted to briefly touch upon this, and I think is it the first and second messenger mechanism? Yeah, we slowly get into that. But I think we're going to stop. We're going to wait till everyone gets back for this. So we're just going to stop once we get down to this aspect here. Okay? And we'll show two different types of hormones and the action that the pancreas secretes to have an effect on the liver. And I believe we talked a little bit about that in chapter 17 when we went through the digestive system. Okay? We probably talked about insulin, but not so much that of glucagon. Okay, we are at 6 minutes, so we'll try to keep that from doubling. At least we'll definitely keep it under 15. The goal would maybe to try to keep it under 10. I don't know if that'll be possible. Sometimes I wonder, for people who actually watch these videos and put the time in, if we go too fast, you can always hit the pause button, and maybe some of you students do that. All right. Do you have this? Is there quite a bit to write on there? Or is it everything, or?
Yeah. Okay. So the first one on the
Non-steroid? Okay.
The first one is done, but then the
Next three?
yeah.
Okay.
Next three.
All right. So you'll have that wrote down. It's not going to mean anything until, again, we get back here all together as a group next week.
I just want to get it done to get it done.
Okay. Well, fair enough.
Can you go back to the or steroid hormones?
This one here? Okay.
Yeah. I just need the last part.
So again, this is kind of one of the things that we talked about yesterday. Okay, these are lipids, these steroid hormones, so they're going to be insoluble in water, so they can be carried in the bloodstream. Therefore, they are secreted in the anterior pituitary because you have a portal system that goes through the pituitary gland that then allows these hormones to be secreted into the bloodstream. To where a hormone like oxytocin, for one, is a good example that's released in the posterior pituitary gland, and that is neuronically controlled, and then that has an effect on that of the uterus and causes it to contract more forcefully. Okay. So what we want to talk about then, okay, if I'm going to try to make 10 minutes, I only have one, but, and again, just like this content, I think the more opportunities or more chances that you see these, the better off you're going to be. Kind of like scouting, the more opportunities you have to possibly see something, the more successful you would be. So all these these are just molecules of glucose, kind of like links in a chain. Doesn't necessarily mean they all have to be the same length, okay? And this would be what we call, now write this down, don't write this down, that's entirely up to you. It won't be this is the first time we've seen it, it won't be the last, okay? So this is a structure called glucagon. Or no, that's the hormone. We want glycogen. Okay? And then over here, we're just going to illustrate a bunch of glucose molecules. Okay? And we'll show you what that significance is, because this is an example of a negative feedback loop. Okay? So all these linked together is called glycogen, and they're all glucose molecules. So what I'm going to do is just write GC in here. All that means is these are glucose units. So you get the idea. It would keep on rolling on down the line, or the chain. And these are all glucose molecules. All right. So what we see happening then, when they are all off on their own, we know these as, again, just individual glucose molecules. But when you start hooking all these glucose molecules together, we form what's called a polysaccharide called glycogen. Okay? So what this does is it takes a lot of sugar out of the blood, and what this does is this lowers blood sugar levels. Okay? Because you had all of these individual units, you link them together, and that lowers your blood sugar level. And that's done by what we call glucagon. Okay? And on the other hand, if we want this to happen, all these individual units to raise blood sugar levels, well, then what we can do, if we want to raise blood sugar levels, we're going to use a different type of hormone. Okay? And to break that apart, okay, I've got to think about this for just a moment. To lower this, I got to backtrack. I got to think about this. We'll start fresh with this when you get back, because I'm trying to remember this from, because the other one's insulin, and insulin will lower the blood sugar levels. That's what actually does this. I'm trying to do two diagrams in one. We'll get back to this when, we'll discuss this when you get back. All right, we'll catch up to you next time.